In this video, we are writing equations of quadratic functions in standard, intercept, and vertex form. We've already talked about how to graph these functions, so now we're going to look at these different scenarios and we're going to figure out how to write the equations based on information that's given. So let's refresh our memory. Standard form is y equals ax squared plus bx plus c. In your standard form, your a, b, and c values are used to help you identify your axis of symmetry, your vertex, your y-intercepts, everything. Technically, your c value in standard form is always your y-intercept as well. Intercept form. Intercept form is y equals a, x minus p, and x minus q. P and q in this equation are representative of your roots, hence the intercept form. Instead of intercept, sometimes you'll hear it called root form or zero form. It's a variety of different things, but the main thing that you need to remember is that it also represents your x-intercepts, which are p and q of your quadratic function. The last equation that we talked about is y equals a, x minus h squared plus k. This is vertex form. In vertex form, the h and k value are representative of your vertex. So instead of finding the vertex like you would have to do for standard form and intercept, it's already given to you. Everything else, unfortunately, you do have to solve for. So in the first group of questions, let's look at questions 1 through 3. So in these questions, let's first read the example itself, and then we'll go through the steps. The very first question says, write the equation of the quadratic function with roots -2 and 3 and a y-intercept of -12. Well, there's something very interesting in this. It already gives us our roots. If you think back to which equation will probably be best for us to use in this, intercept form is jumping out. I've already told you, P and Q are your roots. Remember, there are 4 words for x-intercepts, which are roots. Those words are x-intercepts, roots, solutions, and zeros. So when you're given any kind of terminology like that, you always should know that this is probably going to be your best equation to use. Okay, so let's follow the steps. The very first step says to substitute your roots. So we're going to take that -2 and that 3 and substitute it in for intercept form. So y equals a, x minus -2, and x minus 3. Notice that I'm substituting the x-intercepts in to this equation using a set of parentheses. Gee, I wonder why I'm doing this. If you look in that first set of parentheses, this sign has to change. In the second binomial, it doesn't. If you don't change that first binomial to make it x plus 2, the rest of your answer is going to be completely wrong. The next part is to use the point, which in this case is your y-intercept, unless we've given another point, and you're going to substitute it in as a coordinate. Well, think about it. Coordinates are x and y. Okay, so let me first figure out where's the x and y. There is one y value right here, or one y space right here, and there are 2 x spaces. So we're going to take this coordinate for your y-intercept and we're going to substitute it in. Remember, y-intercepts are written as 0 and then your value. So we're going to take that 0, -12, and we're going to substitute it in. We do not know what a is. That's what we're trying to find. So we're going to make this -12 equals a, 0 plus 2, and 0 minus 3. Don't overthink this or underthink it and think that you just have to cancel out the zeros. Do the operation that's in the parentheses. So we're going to make this 2 times -3. Remember, this is a -3. From here, we're going to simplify. So -12 is going to equal -6a. And then from here, I'll have to divide both sides by -6. So a is equal to 2. That's your a value. Since we were already given the roots of this function, we might as well keep this same form and write our answer in intercept form. Instead of using this first equation that had to change your signs, we're just going to use the second one because this is a lot quicker and a lot easier since we've already simplified our signs. So for our answer, we're going to write this as y equals, the a value we just found was 2, x plus 2, and x minus 3. If I asked on a test or quiz for you to write this in either standard or vertex form, you would have to either FOIL it out, find the vertex, all of that good stuff. As of right now, though, this will suffice for our notes. Let's look at example 2. Example 2 is over the same information. So in example 2, this one says write the equation of a function with x-intercepts of 4 and -4 and a y-intercept of +6. Well, based on the steps that we have above, we're going to do the exact same steps we just did. So, for example 2, we have our roots, our x-intercepts. Remember, I told you there are 4 names for x-intercepts: roots, solutions, and zeros. Those are all the 4 names for x-intercepts. If you need to make a note of that, make a note. So we're going to make this y equals a, x minus +4, and x minus -4. We need to simplify those parentheses. Now we can solve. In this y-intercept, make sure you understand that it's 0, +6. We're going to take that 6 and substitute it in for y. A, this x value needs to go in both of these x's, not just one. So 0 - 4 and 0 + 4. Keep in mind, when you are simplifying this, all you're doing is you're combining the parentheses. So in that first parentheses, 0 - 4 is not 0. A lot of students will think that just because you have 0. And 0 + 4 is 4. We're going to multiply. And then we're going to isolate a. To isolate a completely, I'm going to divide both sides by 16. So divide by -16. Do not forget that negative. So up here, we're going to simplify it to make it, they're both divisible by 2, so we're going to make this -3/8 equals a. Since the directions do not specify how to write the equation, let's just write it in intercept form since we already have the layout of how it's supposed to look for your answer. We just needed this a. So we're going to write this as y equals -3/8, x minus 4, and x plus 4. Keep in mind for both of these questions, if you were different and you put x plus 4 here and x minus 4 here, you're fine. You'll still get full credit. Same thing for the last question. If you were to put x minus 3 and x plus 2 and its opposite parentheses from where it's currently at, you would still get full credit. You just need to make sure the x plus 2 is positive, the x minus 3 is negative, and down here that these have the correct sign. Right now, pause the video. Try example 3 by yourself. Let's look at example 3. In example 3, I'm not going to go through all of the steps, but I will write out the answer for you. If you have a question, pause the video, send me a message. In this final answer, you should have y equals 1/6 parentheses, x plus 3, and x minus 3. This should be your answer. So on this page, we've talked a lot about intercept form. Let's look at a different form. In the first question down here, I'm not going to worry about the steps just yet. It says write the equation of a quadratic function with f of -1 equaling -7 and a maximum value at f of -2 equals -1. Oh, okay. Well, let's see what we're going to do. In this question, we need to use vertex form to substitute our vertex. Well, if you think about it, what are they talking about? Where's the vertex? If you think back to the notes that we did over graphing, maximum is kind of like a big hint that you're going to have a vertex. It has a maximum value at 2, f of 2 equals -1. Remembering back from the first cycle of this school year, f of 2 equals -1 is actually a coordinate. That coordinate is 2, -1. That's your vertex. The other coordinate that's on your quadratic function of f of -1 equals -7 is just a regular point. This is acting as the y-intercept on the last page. So when I read that first question and said use vertex form, you're given a vertex. Use vertex form. It's quick and easy. And then we'll substitute the vertex coordinate. So thinking back to the first page, y equals a, x minus h, this is x, this is h, x minus h, Excuse me. Let's try that again. This is h, this is k. And if you're wondering, wait, why did you change it? Let's look back on the first page. In vertex form, you're looking for h and k. The x and y piece, guys, comes from that coordinate, so do not plug that in. So, down here. So we have x minus h, which is 2, squared, plus k, which is -1. This looks better. Main reason why I always use parentheses to substitute this in is to see if any signs are going to change. We're going to make this y equals a, x minus 2 squared minus 1. You can't keep both of these signs, so keep the sign that is kind of more dominant. Positive times a negative will always give you a negative answer. Just like we did on the prior page, we're going to substitute the other point and solve for a. In this case, we have -1, -7 as your other point. This is your x, this is your y. We're going to simplify inside the parentheses. -1 minus 2 is -3 squared minus 1. -3 squared is 9. We're going to go to do two things. We're going to add 1 to each side. So we'll have -6 equals 9a. And then we'll divide both sides by 9. This is basic solving equations from Algebra 1. If possible, reduce your number. In this case, we can reduce this to make it -2 over 3. That's your a value. Okay, well, if you look back at the top, the directions didn't say exactly which form it wants your answer in, so since we already started this in vertex form, let's keep it in vertex form. The only value I need is that a value. So we're going to write this as y equals a, x minus h squared plus k. That's your answer. Let's look at the next page. Write the equation of the quadratic function with a minimum point at 3, -5, or 3 equals -5, f of 3 equals -5, and f of 1 equals +2. Well, it gave you this terminology. You have a minimum point at f of -3 and f of +1 equals 2. Well, the main thing that you need to figure out is which one is the minimum and which one's the x and y coordinate. Think about it. Which one's which? The first coordinate, which is 3, -5, is your vertex. The second coordinate, which is 1, +2, is just your regular point. This is your x, this is your y. When you're writing or when you're reading this out, when it says the minimum point at here, don't read any further. This is your minimum point. The one that's behind it is just a regular coordinate that's on your quadratic function. Take this information and let's substitute it into vertex form. Y equals a. This is h. This is k. I always label them out because I always want to make sure I have the correct coordinate labeled. X minus h squared plus k. Simplify the parentheses if possible. Now that we have it in its kind of vertex form, all we need to find now is the a value. So we're going to make this y equals a, the y value, which I've already labeled, is +2, a, x, which is +1, minus 3 squared, minus 5. If you're like, wait, where's she getting this? This coordinate right here. Remember, I labeled it my point. Let's simplify. In that parentheses, 1 minus 3 is -2 squared, minus 5. We're going to add 5 to each side. So 7 is going to equal 4a. Probably should have simplified that first before I subtract or added. So let's do that. I want to make sure you guys see exactly what we're supposed to do so you don't get confused. So 2 equals 4a minus 5. Now we can add 5. Since I'm running out of space, I'll put my answer up here. We're going to have 7 equals 4a, and then we'll isolate a by dividing by 4. So 7 over 4 is going to equal your a value. Using the vertex form that we already have for our equation, let's write out our answer. Y is going to equal 7 over 4 times x minus h, which was 3 squared, plus k, which is negative 5. Don't put 2 different signs, put 1. Right now, look at question number 6 and try to solve it. I want you to write this answer in vertex form. Let's read it first. It specifically says, write the equation of your quadratic function in vertex form. So that's the hint telling you what form it needs to be in. You have 2 zeros, -1 and +3. And you have a maximum value of 8. Try this out before I do it. What is this going to look like? This question I will go through. For this question, we know we want our answer as y equals a, x minus h squared plus k. That's vertex form. When it says that you have 2 zeros, it means you have -1, 0 and 3, 0. Those are your x-intercepts. Those are your roots. The maximum value means that you have some coordinate, h and k, that has 8 in the y spot. Whenever we're given a maximum value and it just gives you a number, it's always giving you that y coordinate for your vertex. So technically, they're giving you bits and pieces of things that you don't have just yet. One of the things that they are giving you, like I said before, is the k value for your vertex. We're missing the h. Okay, well, let's think back to graphing. When you were graphing a intercept form function, how did we find the h value? Because technically, we have 2 intercepts. We have 2 zeros. How did we find that h coordinate? If you think back to what we did for graphing an intercept form, we had to take p and q and kind of average it together in a way where we were actually finding that value. If you don't remember, here it is. In the graphing of intercept forms, we took the axes of symmetry for intercepts, which are p and q, which remember are your roots. We found the kind of midpoint of sorts for it by finding the average, and that was our axis of symmetry, which we labeled here. So that's what we're going to do on this page. We're going to use that formula, p plus q over 2, to find out what exactly our coordinate is going to be, specifically for the axis of symmetry. That's why it's important for you to know the axis of symmetry is the same as the x value or the h value for your vertex, same exact spot. So let's find the axis of symmetry. We're going to take x equals negative p and q, technically, are already here. So negative p plus q. And when I say negative p and q, I just know that the p value is negative, so I'm just labeling it as -1. If you're like, wait a minute, I want p to be not -1, I want it to be 3. You're fine, switch it around, but it's still going to give you the same answer. This is going to give me 2 over 2, which simplifies to 1. So if you think back to what we're trying to find, this is your vertex now that we found the h value for your vertex, which is technically the x-coordinate of your vertex. Luckily for us, we're going to use this vertex, and we have 2 different coordinates to pick from. We can either use the x-intercept or the y-intercept. That's the only other point we're given, so we have to use one of them. Let's use a +3. I'm less intimidated by positives. So we're going to make this still in vertex form. Keep in mind, we're writing this in vertex. Y equals a. Your vertex is x minus 1 squared plus k, which is 8. I'm going to simplify my parentheses. And now I need to find the actual a value for this equation. I'm going to use the coordinate that I have here, which is x and y in green, and I'm going to substitute it in. 0 is going to equal a, 3 minus 1 squared plus 8. If you use -1 instead of +3, 0, you're going to get the same coordinate. So we're going to make this 0 equals a 2 squared plus 8. 2 squared is 4a plus 8. I'm going to do two things. I'm going to subtract 8 on each side. So negative 8 will equal 4a. And then the last thing I have to do is divide both sides by 4. So negative 2 is going to equal a. So when I write this out in its form, I'm going to make this y equals a x minus h, which was 1 squared plus k. This is your answer. Uh-oh, I just realized I did something. Hopefully you guys caught it. On question number 3, I don't know where I got 2 3s from. I'm sorry about that. Here, you should have negative 2 instead of 3. This is your final answer. Don't know how I messed that up. Oh well, but this is your final answer now. If you have any questions though, let me know. Okay, moving on. We did that one. Question 7 and 8. So doing these questions are going to include arbitrary points. Arbitrary points are just random points that are on your quadratic function. So for this question, it says we're going to write the equation of the quadratic function in standard form, going through these 3 points. Each of these points are in the coordinate xy, 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 each of the points. When given arbitrary points, so I'm reading step 1 at the very top, when given arbitrary points, you're always going to use standard form. If you remember from the first page, standard form looks just like this. When I say use standard form, I mean take these coordinates that I have and plug them in one by one to standard form. So that's the first thing we're going to do. So down here at the bottom, I'm going to try to keep this in view. For point 1, 6, we're going to write it in its own standard form. We're going to take the 6, which is your y value, and put that in first. A times 1 squared plus b times 1 plus c. Okay, simplify it. This is going to give me 6 equals 1 squared is just 1a, which you can just write as a, plus 1 times b is just b, plus c at the end. That's one of your equations that we're going to use. For the next one, point 3 and 26. The y value is 26. 3 squared is going to be plugged in for x, plus b times 3 plus c. C is going to be the same. Simplify this equation to make it for the second one. 26 equals 9a plus 3b plus c. Do the same thing for the last one. Negative 2 and 21. So we're going to write this out as 21 equals a, negative 2 squared, plus b times negative 2, plus c. So this is going to be my third equation. 21 is going to stay the same. 2 squared, negative 2 squared is 4a, that's positive. 2 times b is negative 2b plus c. All 3 of these equations is a system. I've technically done steps 1 and 2, which is to substitute each point into the standard form, like we just did here. Now we're going to solve by either elimination or substitution for 3 variable systems. So, in the space we have left, let's see what we can do. If you're looking at these 3 equations, the first thing we need to figure out is what variable we want to cancel. Honestly, I'm not going to lie. C is the easiest variable to cancel. All of them are the same. There's no coefficients in front. All we're going to need to do is multiply by some negatives. So the first thing I'm going to do is use equations 1 and 2 and cancel out c. So my first step is to take the first 2 equations, 6 equals a plus b plus c, and 26 equals 9a plus 3b plus c, and we're going to cancel out the c's. It doesn't matter which equation you use. I'm going to use the first one and multiply the whole thing by negative 1. So negative 6 equals negative a minus b minus c. The second equation is going to stay the same. The c's cancel. So we're going to be left with 20 equals 8a plus 2b. I'm going to label this as equation A. For my second step, we're going to either need to use the first and last equation or the second and last equation. The whole point of this is, if you remember back from 3-variable systems, we have to use this third equation. You have to. I think the first equation will be the easiest. So 6 equals a plus b plus c. And 21 equals 4a minus 2b plus c. Let's cancel out the c's. I'm going to make this whole first equation a negative 1. So let's distribute. We're going to make this negative 6 equals negative a minus b minus c. The second equation stays the same. In this equation, the c's cancel again. This is going to leave me with 15 equals 3a minus 3b, no c. This is your second equation. From here, we're going to need to solve. We have one equation and we have a second equation. This one and this one. This is what we're going to use to solve it as a regular system of equations. If you're running out of space, the back of this page should be blank, or use the paper in your spiral. So over here, we're going to, third step, we're going to solve this system. 20 equals 8a plus 2b. 15 equals 3a minus 3b. For me personally, I'm going to get rid of the b's. I feel like that would be the easiest thing and would be less threatening. So I'm going to multiply the whole first equation by not 2, but 3. And then the second equation, I'm going to multiply it by 2. This will help me cancel out the b's. One of them is positive, the other one is negative, so it works beautifully. So 3 times 20 is 60. 3 times 8 is 24. 3 times 2 is 6. 15 times 2 is 30. Equals 2 times 3 is 6a minus 6b. Both of the b's cancel. We're going to make this 90 equals 6 and 4 is 10. That's 30a. All we need to do from here is divide both sides by 30. So a is going to equal 3. That's your a value. Remember, the whole goal of this is to get it in standard form. So up here in this space, my final equation is ax squared plus bx plus c. I'm going to put those items in this space. So I just want to have one space so I don't have to keep looking around my paper. Unfortunately, I'm going to actually, you know what? I think I can fit the rest of these in. Step 4. Let's go ahead and find one of the other variables. Think back to 3-variable systems. Once you find one of the equations, what can you do? Well, we still need to find a b value and we still need to find a c value. Which one will be the easiest one to find next? Well, your b value is the easiest one to find next. You can either use the original b equation or the original a equation. Either one will work. Use the originals. You can technically use these, but it just starts getting tricky and I don't want you guys to overthink it. Use one of the originals to make your life easier. So for step 4, since I've already zoomed in this much, we're going to use the b equation, 3 times a minus 3b. Well, your a value that we just found was 3. So 3 times 3 minus 3b. 3 times 3 is 9. I'm going to subtract 9 on each side, and I'm running out of space. 15 minus 9, is going to be 6, equals negative 3b. I'm going to divide both sides by negative 3. So b is going to equal negative 2. That's your b value. Find your c value. If you don't remember how to do this, look back at your notes over 3-variable systems. So I'm inputting in my b value, so that's negative 2x, that's that blank. The constant is going to need to come from using one of the original 3 equations, either the first, second, or third. You pick. I'm lazy. I like to use the first equation because it's less intimidating and it's fairly simple to do. So 6 equals a plus b plus c. So 6 is going to equal a plus b plus c. A is positive 3, b is negative 2, and c is my constant. Negative 3 plus 2, 3 plus negative 2 is positive 1. I'm going to subtract 1 on each side, so c is going to give me 5. That's that constant at the very end, and it's technically my y-intercept. This is my answer. That's it. Make sure when you write these out that you write it in the form that we're asking for. In this case, we were asking for standard. Taking in all of the information we just did for question 7, pause the video now and do question 8. It's a lot easier than the last one. Try it. Looking at question 8. This one, again, you're going to need to start with 3 arbitrary points, and you're going to need to find their equations in standard form. So for the first equation, we're going to use 0, 0. Don't overthink it when you see 0, 0. It's actually a very nice equation. So for the point, which is your origin, this will turn into, let me not put an equal sign, let's put an arrow. 0 equals ax squared plus bx plus c. Well, think about it. If you're squaring 0, you just get 0. 0 times a is nothing. 0 times b is nothing. So this is a beautiful equation. C is equal to 0. That's your first equation. And technically, if you wanted to write it in the correct form, it's 0 equals c, because it's in the same form that we have here. But c equals 0 is technically your answer. Let's find our next one. So we're going to use, for point, negative 1, 7. We're going to substitute in 7 equals a times negative 1 squared plus b, put the b first, times negative 1 plus c. So our second equation is going to be 7 equals a, because 1 squared is just 1, minus b plus c. And then for the last equation, p is 6 and 42. So 42 equals a times 6 squared plus b times 6 plus c. So this will be my third equation, is 42, 36a. That is supposed to be an a. Let's try that again. A plus 6b plus c. Okay, well, let's think about it. Technically, these are my equations. C equals 0, 7 equals a minus b plus c, and the last one. Think about it though, guys. If c equals 0, what can we do with that? We have a c here, we have a c here. Let's try plugging it in. When you substitute it in, it will turn your system into c equals 0 or 0 equals c. When you substitute in 0 here, that's just going to go away. So you're going to have 7 equals a minus b. And if you plug c in here, that's going to cancel. So you're left with 42 equals 36a plus 6b. This is the system you're solving. Luckily, you already know if your equation is going to be in standard form, y equals ax squared plus bx plus c, the c value at the end is 0 because your c value here is 0. All we need to do now is find the a and the b. This system at the bottom is going to help you do that. The first equation is technically useless to help you solve the system because it's already your c value at the very end of your equation. So right now, the only thing you need to do, it's not a 3-variable system you're solving, it's a 2-variable system. This is what we're solving. So the first thing we're going to have to do is set these equations equal to each other, or not equal to each other, but we need to solve them. So I'm going to put them in their normal standard form. I'm just moving the equal sign to the very end. And I need to think. What could I cancel? Well, 6 is a less intimidating number than 36. So let's take this whole first equation and multiply it by positive 6. And the reason why I'm erasing this negative is because this 6 is already negative. Once I do that, they'll cancel. So we're going to make this 6a minus 6b is going to equal 7 times 6 is 42. 36a plus 6b equals 42. The b's are going to cancel. So 36 plus 6 is 42 again, which equals 42 plus 42 is 84. Your a value is 2. What we just found is the a value for your equation. So at the top of the page, we're going to put in the a value, which is 2x squared. Don't forget, the x squared needs to be in its standard form. So I just need to substitute that a value, which is here. Let's find the b value. So go ahead, find b. For step 2, to find b, it's pretty easy to use the first equation, well, really the middle one, 7 equals a minus b, and I'm going to substitute in the a. When I said that I'm using this equation, I'm using it from the original. You could use this one if you want, but I usually like going with the originals as much as possible. It won't affect your answer though. So 7 equals 2 minus b. The 2, that parentheses, isn't going to change anything. So 2 minus b. I'm going to subtract the 2 on each side. So 5 equals negative b. And then I'll divide both sides by negative 1. b is equal to negative 5. So at the top of the page, I'm going to make this minus 5. Ooh, that's a 5. X. All right, let's make this a lot cleaner. So your final answer that I'm going to box and highlight is y equals 2x squared minus 5x. This is your final answer. That's what I want to see.